starts talking about cost behavior. And some of the objectives we'll talk about is really how to define and describe costs. They behave differently, and we're going to categorize costs into fixed, variable, and mixed. We'll talk about resources and activities. We'll talk about cost estimation, and we'll talk about how to separate a mixed cost into fixed, variable, and using a high-low method. And that's the main one we're going to focus on. We'll talk about scatter plots and least squares and regression. It's just more that I want you to be more aware of them as opposed to actually crunching the numbers. So there will be parts of this chapter that we're not going to cover, so therefore I would not quiz you or test you over them, and the Cengage Now problems would not, would not be involving those topics that we're going to skip. In your book, Chapter 3 starts on page 74, and the first part of the chapter talks about cost behavior, and it says basically how does the cost change based on the level of output. That's really what we're talking about here. If this cost doesn't change based on output, or does it change directly with output, or is there some other pattern we need to look at? So it says a fixed cost does not change as output changes, and then a variable cost increases in total with increase in output and decreases with output. So a fixed cost is just something that never changes. A good example is a building. If you just took the Cleveland Center, for example, and said the mortgage on that building and the insurance are the same no matter how many students are in it. If there's one student versus 300 students, those things don't change. They're always the same because that cost has no correlation to output. A variable cost, though, would be very different. In examples I've been given before is if we're manufacturing desks, if we're a desk manufacturing company, and wood is the primary raw material that we acquire to build a desk, we're not going to buy wood without the intent of building a desk. So the more desks I make, the more wood that I buy, and the more that I end up using. So there's a direct correlation between output and the cost of this raw material to build my product. So a cost object, we've talked about those a little bit. Basically something that we assign cost to. And so basically just a cost object is anything that we need cost information about to help us make decisions. For manufacturing and merchandising, it's typically the product that we make. For merchandising, of course, we're buying finished goods and selling them, so we've got that cost information. For manufacturing, we're manufacturing a product and then selling it. So it's typically a tangible product, obviously something we can look at and see and touch. Now for a service firm, it's an intangible product that or really it's a service, of course, it's intangible, we typically can't see a service. It's the cost of delivering a service, though. We can definitely measure that. And so for measures of output, it says activity drivers explained change in activity. So what we want to figure out is as activity changes and output changes, how does cost change? And so activity drivers can be divided into unit level or non-unit level. And unit level is basically, this is on the top of page 75, a little bit on the bottom of 74. Unit level is basically, they change as the units produce changes. So basically the more units we make, the more that cost changes. And non-unit basically deals with how many setups there are, how many work orders there are, engineering change orders, inspection hours, material moves, things like that. We'll get into that in much more detail, those two topics, in Chapter 4 when we talk about activity-based costing. So a fixed cost simply does not change, excuse me, it just stays the same in whatever the relevant range is. Now the relevant range is a range where we are efficient, basically saying in this capacity our fixed costs will stay the same. Okay, So if we have a factory that makes desks and our output at the most is 1,000 a month, let's just say that's not the capacity we have because we only have so much machinery, so many people, so much plant space to make 1,000 desks a month. But if orders start coming in where we know we can make more and sell them, and we would then consider maybe adding on to our factory, buying more machinery, hiring some people, and our capacity will definitely go up, but so would our fixed cost. So that's really the concern, is that as fixed costs go up, that means we're adding a new relevant range. So basically the relevant range with anything is, here's where our capacity is. There's usually a bottom and a top to it. And as long as we're within that relevant range, costs will behave a certain way. So you'll see that come up in some of the problems that you do, is within this relevant range, here's our cost structure. And this, what they mean is, above that or below that, we probably would adjust our fixed cost structure. So let's just say demand goes down severely for our product, and we have excess capacity. Maybe we'd sell some machinery. Maybe we would try to sublease our factory, a part of it, to somebody else, so we would reduce our fixed costs. An example they give us in the book, and so the same data that you see on the screen here in a few slides that we'll use as an example are also in your book. And the example is that we have an audio company. They make speakers. And there's a department that produces a voice coil that goes into the speaker. And there's 2 production lines that make up 100,000 voice coils per year. There's a line manager overseeing this that's paid $60,000 a year. For production up to 100,000 units, only 1 manager is needed. But if we were to make more than that, let's say we make up to 200,000 units, then we need to hire another manager, because it would just take that much more, it would take 1 more person to be able to oversee the production. So to think of it this way is, up to 100,000, my fixed cost is 60,000, right? My supervising cost is typically fixed. It doesn't change within the relevant range based on the voice coils produced. And so you can see one thing about fixed cost: the more units we produce, the lower the fixed cost per unit is. So we're making, we're paying somebody $60,000, and then up to 100,000 units is their capacity, basically. And that's the relevant range for 1 person. But if we need to produce more than 100,000 units, we need to then hire another supervisor, and then you can see how the fixed cost per unit changes. So with fixed cost, the more units produced, the lower the fixed cost per unit. And so you can see kind of how that works here with the costs and everything else. And then just a graph, a fixed cost graph, and the same graph here is on page 76. Just literally is horizontal. It just doesn't change. It's just, no matter what my production is, that's what it is. Now, of course, we go from that red line goes up to 100,000. That is 60,000 to 100,000 is the $60,000 cost. Their capacity is up to 100,000 units. But as soon as we get above that, then we have to go draw another horizontal line at 120, and that can take care of us up to 200,000 units. So variable cost then is basically, there's a direct correlation between that cost incurring and a change in activity driver, basically units produced. Typically is one we'll look at. And the total cost of direct materials for each level of production varies, but unit cost stays the same. So think of it as, quite often it's the raw materials needed to produce a particular product. And so for this company, every time they make a voice coil, the direct material to produce that coil is $3. So that's a variable. I'm only going to incur that cost if I make a voice coil. So if I make 40,000 voice coils, I multiply that by 3. That's $120,000 cost. 80,000 coils times 3 is 240, and so on. And so there's a direct correlation between output and the cost. So that gives us what we call a linear correlation. And so it just moves very rationally, it moves the same way. 200,000 units means $600,000 worth of cost. 0 units produced, 0 cost. 40,000 produced, 120,000 in cost. That direct correlation is very important. Then you can have products that have a nonlinearity, and of course that's a little bit more difficult. I just want you to be aware of that for the most part. Is not every product we produce is going to have that direct correlation, because sometimes you have to buy batches of raw materials, and maybe the more you buy, the less the cost is, or so on, or sometimes maybe you're working with a scarce resource, and the more you buy, the more expensive it is. But it can, those variables can be nonlinear, just to be aware of that. And then we talk about relevant ranges for variable costs. And on page 79 they show this graph here. And obviously you can see my relevant range here is kind of this area where my error margin is kind of small. So even if I have a product that's nonlinear, but I'm kind of using more of a linear assumption, just because that's easier to compute costs and come up with cost tables and things like that, I'm going to get close. But then outside that relevant range, you can see the large error region gets, it's pretty big up here. So I got to say, okay, I have to have new assumptions if I have production above that relevant range. Then we come up with mixed costs. So a mixed cost has both a fixed and a variable component to it. Cell phone plans might be a good example of a mixed cost. Typically there's a cost just for having a line. So if you go to a company and say I want a cell phone, there's a cost for just having a number. And most places now give you unlimited texting or unlimited calls quite often, as long as your calls within the same company. But data might be one that's kind of mixed now, because you can buy data up to a certain point that covers so much gigabytes per month. But once you get beyond that, now all of a sudden you got to pay a rate. Whatever that rate per gigabyte is, 15 bucks. Who knows what it is. But once you get above and beyond that, then you got to pay a new rate. So just be aware that a mixed cost has a fixed component and a variable component. And so they give us a formula there. And don't be intimidated by formulas. There will be a few formulas in the class. Definitely don't be intimidated by those. They show us a nice graph, which we'll get on the screen here in a bit on page 81. But it just says y equals fixed cost plus total variable cost. So basically all the costs that go into mixed is a fixed component and a variable component. So it says y equals total cost, which is a mixed cost. Okay, so it's really not that difficult of a formula. And so the example they're giving us for our speaker company is JCM's sales costs are mixed, because they have 10 sales reps out there selling their speakers to whoever their consumers are, probably audio stores, electronic stores, and so on. And they pay their salespeople $30,000 per year of fixed salary, and then each salesperson receives $5 as a commission to sell a speaker. And so the fixed part of that obviously is 30, and the variable part of that is obviously 5. So the formula for total cost is 300,000, which is the 30 times 10, plus the 5x, 5 times the quantity of speakers sold. That would be their total mixed cost for sales. And so the example they've given us then is just to say, okay, I've got this fixed component over here of 300,000, 10 times 30. I have a variable component here based on speakers sold. So 40,000 times 5 is 200,000, 80,000 times 5 is 400,000, and so on. Total is just the sum of these two columns. And then if I take my total cost of 500 divided by 40, my selling cost per unit is $12.50. And so obviously this is going to go down the more I sell, because I am kind of thinning out my fixed portion with the more product that I sell. Okay, so here is the graph that's on page 81 that discusses or shows you the fixed and the mixed portion. So the line's linear, but it doesn't start down here at the lower left. It starts at the $300,000 mark because that's my fixed cost. So if I sell 0 speakers, in theory, I'm going to have $300,000 worth of sales salary. Now, if I sell 0 speakers, in reality, I'm going to be probably firing some people because they're not doing their job. But that's how we would plot the cost. Before I get on to this topic, the book does mention time horizon. There wasn't a slide about it. It's on the bottom of page 80, and it talks about the long run and the short run. And this kind of is a grayer area in terms of time horizon. Typically, what we say in accounting is, in the short run, it's hard to change a fixed cost. Okay, in the long run, all costs are variable. And what that time horizon really is kind of depends on the company. But in general, let's just say my sales have gone down. I'm a speaker company. I've got a factory where I make speakers. And let's just say the economy is kind of hurting, and I'm not making nearly as many as I can, and so I got to cut costs. Well, if I've signed a lease for my factory, that's why we say in the short run, it's hard to change fixed costs. If I've got a lease on my factory and I've got all this machinery that I've acquired over the years to make speakers, it's going to take me a while to unload those costs. I have to sell some of them. I have to maybe sublease my factory or look for a smaller space that's cheaper and move into that. It just takes time. And I potentially have some contracts signed with labor. Maybe there's a union where I've got an agreement where I can't let people go unless certain things happen, and so I'm stuck with some extra labor. Whatever it is, I can change my cost structure. I can definitely do that. It just takes time. So in the short run, we typically say costs are more fixed, but in the long run, everything's variable. Now, generally, as we put information together, crunch our numbers and our problems, we're not really concerned about that, but I just want you to be aware of that. Okay, next topic is resources. Starts from the bottom of page 81, and it just says here, a resource is an economic element that enables one to perform an activity. So it's those things that we do that allow us to manufacture our goods, sell our product, deliver a service. Okay, what are the things we need to do what we want to do? If we're a business that manufactures speakers, obviously we need to acquire raw materials, pay for people, have a factory, build our speakers, and sell them. Okay, so we acquire resources needed to perform an activity. So as we acquire resources, of course, we obtain capacity by buying raw materials, by hiring people, by building a physical plant. Practical capacity is where that activity is performed efficiently. It's kind of like, here's the sweet spot. Here's the amount of resources that it makes sense to make our product, and above that and below that, we're not as efficient. So they talk about a flexible resource. A flexible resource then is at the bottom of page 81, and it's supplied as used and needed. And so the quantity of resources applied is also the quantity of resources demanded, and there's no unused capacity. So it's like buying raw materials just as we need them to manufacture the product that we're going to ultimately sell. So we only buy raw materials as needed to manufacture our product, therefore we're not wasting anything. A committed resource is supplied in advance of usage. Typically more of your fixed type of cost, machinery, a physical plant. Maybe if it's a restaurant, it's a store, it's a location of something. And so committed resources are typically purchased in advance. You've got a quantity of that resource obtained. I've got so much manufacturing capacity, so much floor space in a store, so much ability in a restaurant to seat people and cook food and serve so many people at a given time. And so it's possible to have unused capacity. In fact, it's probably most likely going to happen depending in that with a committed resource. But be aware of those. Just that committed resources are described more on page 52. Okay, next is step cost behavior. And step costs are costs that kind of move up in chunks. Maybe it comes down to when we hire somebody, of course, then we are committed to paying their salary. It could be resources. We can't just buy a minimum of a resource. When we buy it, we have to buy a big batch of something. That's basically how it's acquired. So the second I incur these big costs, my cost goes up in a step, in another chunk, another level. So two kinds of step costs. I've got variable. Follow a step cost behavior with narrow steps. So basically, that quite often that deals with acquiring more of my raw materials. Or step cost, which typically is I'm increasing my fixed costs, and they're going to go up another level. And typically, these steps are wider because there's a relevant range involved. And so basically, just kind of like our $60,000 line supervisor, up to $100,000, up to 100,000 units, I could just have one supervisor. But when I got above 100,000 units, now I needed to hire another supervisor. And so there's another step in my fixed costs, but I got a relevant range that it increases with each step. And so the best way to show you that is just to graph it. So here's a step cost that typically deals more with the flex. That first one, the step variable behaviors, which typically is your raw materials, which are more flexible costs. And possibly it's just that I have to buy batches of my raw materials. So every time I buy a batch, my cost goes up. And then step fixed typically is in the capacity. So this is engineering change orders is the example they give us with this one. But basically, every time I hire another engineer, notice that my operating range moves to the right. It moves up and to the right. So my cost goes up, but I can handle more orders. Okay, in this example is 2,500 orders. So every engineer that I hire is going to cost me $50,000. However, that increases my operating range, my relevant range, by 2,500 hours, or orders, I should say. Okay, so the challenge with cost accounting and managerial accountants is the fact that many activities have both a mixed or have mixed cost behaviors, and when they're mixed, of course, that means there's a fixed component and there's a variable component. And so how do we divide that? How do we look at a cost and go, okay, I know it's mixed, but what part of that is fixed and what part is more variable? And how do I separate that out? Because I need that information separated to make good cost analysis. And in future chapters, we'll see how that will be important for us. So many companies or many activities, if I can talk here, have characteristics of both. It says an example, a power department acquires long-term capacity for supplying power by investing in a building and equipment. It says also acquires fuel to produce power on an as-needed basis. So a power company acquires a lot of committed costs and building a power generation, building a power plant, building substations and lines to deliver that power to customers. Obviously, once we commit to that, that's a very fixed and committed cost. But then let's just say it burns coal or natural gas. You're only going to buy that as you need it. Okay, so there's the fixed part and the variable part to it. And so we have to separate those costs in order to analyze them and figure out ultimately what it costs us to make our product, deliver our service, and so on. So there's lots of methods to get that done, and one method that they talk about here at the top of the screen is the industrial engineering method. It's on page 87. It says it's more of a forward-looking method done by industrial engineers, obviously, people whose job is to study processes and figure out all the activities, all the things that have to happen to manufacture our product or deliver our service. And so it's done by Physical observation, analysis. Quite often it's interviewing people who are involved in production and management of activities and talking about what has to happen in what quantity to complete a process. Okay, so very forward-looking, very time-intensive, very expensive, and also kind of expensive to implement in industrial engineering. Or you have the account analysis method, which basically is just saying, okay, let's look at my costs, and typically you're looking at your general ledger. And so your general ledger, just if you don't remember, is a list of all the accounts in your accounting system. And quite often in a business that's very heavy in manufacturing, you're going to classify your costs generally as fixed or variable. And you know you're going to have some costs that will be mixed, of course. And so you try to organize your chart of accounts and all the accounts in your ledger, at least when it comes to cost type accounts, as fixed or variable, or some would be mixed. And then even with your mixed accounts, you could have a sub-account that would have a portion that's fixed and a portion that's variable. So that's one way to do it, just to look at your accounts, organize your accounts, and try to figure out which costs are variable and fixed based on your accounting system. So we looked at this formula before, just a few screens ago. So Y is total cost, Y is total cost, F is fixed, B is variable. So my variable cost per unit times X, which is the measure of output. And that's how I come up with my total costs. And so the methods that are that we have to figure this out, there's several. The one we're going to focus on is the high-low method. That's really the only one that I've given you in Cengage now, is the high-low method. So that formula in the previous slide was on the bottom of 89. And on your own, a good corner, there's the book has what they call cornerstones. It's kind of where they show you a particular problem, give you some numbers, and kind of walk you through the process of solving that. A good one is on page, starts on the bottom of 87, then is on pages 88 and 89. That'd be a good one for you to go on through on your own. And the formula right here is that you see on the screen is on the bottom of page 89. And then another cornerstone is cornerstone 3.4, which is also on pages 90 and 91, and that walks you through the high-low method and how to compute it. So the high-low method says take 2 points, the high and the low, by volume and activity, and determine the slope and intercept. So slope and intercept is basically just the line on a graph, just basically what degree of slope is it. Intercept is the fixed cost, and slope is the variable rate. So intercept is where the lines kind of start. So take 2 points, the high, low, by volume activity. So what you're doing is you're looking at a table of data, and they show us that table on page 90 in Cornerstone 3.4. You can see there's a table there, and it gives us the months in a year, and we're going January through October. It gives us materials handling cost for each of those months and the number of moves that caused those costs to happen. And what you're doing is you're plotting that. You're finding the high cost and the low cost, and then you're using that information to compute and figure out what your cost, what the fixed part of it is, and what the variable is. Okay, so I'll let you take a look at that, and to me it's very straightforward, very self-explanatory. You'll have a couple of those in Cengage now. So advantages, it's objective, it's easy, very simple to calculate, very easy. That's why it's used a lot, because it's very simple. Now, however, a disadvantage is you could have an outlier. You could have had a month that was very non-typical, and if you don't throw that out, you're definitely going to negatively impact the results you come up with. And so you have to look at your numbers and just be a little bit objective and go, okay, that month really I believe is an outlier. And you might need to do some investigation and discussion with the people who are involved in materials handling or whatever the item is we're looking at, and try to figure that out. So you can't just necessarily look at the data and go, okay, I'm going to use the high point and the low point. It could be that the high point was an outlier, and if it was, we got to throw it out, use the next highest point below that. Okay, then just the other methods I want you to be aware of. There's nothing in the Cengage now that's going to have you create them or do them. But the next one's scatter plot graphing. Basically just taking information. So for example, if we're doing scatter plot, we could have taken the same data that's in the cornerstone on page 90 and graphed it. And then once we graph it, we're basically drawing a line, and that line gives us our variable cost. Advantages: allows for visual inspection of the data. Here's the outlier will show up really good if we graph it. If there's one number that's just way off to the side, that's an outlier, right? So it's very easy to see. Disadvantages: it's subjective, and a lot of these still are subjective. So it's basically just taking the data that we have and graphing it, and you can see that a lot of those lines have a very linear point to them once we connect the dots. So you can see here, points 1, 3, 10, and 5 connect in a very linear way. And we've got some other ones that are close and a few that are far away. You might say possibly items 4 and 9 potentially are outliers. They're not super far off the line to really be an outlier, but maybe. If we had something way down to the right or over to the left, that would definitely be an outlier. So just basically, they're just going to show us some graphs for the scatter plots here. Okay, so that was, then also need to be aware of the method of least squares. And that is, I don't really have a good slide for it, but that's at the bottom of page 95. They also talk about it on page 96. So just be aware of that one. Then also be aware of regression. And regression is probably the next one that's used a lot in industry and out there in the real world. You can use Excel to compute regression. Quite often you can just do an Excel add-in that kind of gives you a little bit more power when it comes to doing regression analysis. And you can buy software that will do this for you too. So just because everybody's got Excel, regression analysis is fairly popular. So with regression, you're entering data, and it says here just basically if you have Excel that has the regression stuff in it, here's what you can do to do a regression analysis. So basically you're looking for statistical correlations between the numbers to help you calculate them. I didn't mean to skip this. So basically just taking the same data we've been looking at and just dumping it into Excel, which obviously makes sense, and then coming up with your regression, and then using the formulas they come up with to help you figure out the slope and then what is fixed versus what's variable. Okay, so basically it is the best method. It's the one that's going to give you the best answer, but it's going to take more effort to get there. Okay, so I am going to stop right there and just say, just be aware of least squares, scatter plot, and regression, but I'm not making you crunch the numbers on those. There will be number crunching for high-low, so definitely be aware of that and review the high-low example in the book. Otherwise, as you get done with a chapter, a great review is to, once you get to the end of the chapter, just make sure you're kind of aware of the terminology that they give us. I try to emphasize the terminology I think is important as we go through it. So key terms are on the bottom of page 115, top of page 116. There's some review problems then. They start on page 116, where both the problem is there and the solution is there. So just another example to work through something. There is a resource users and cost behavior review problem on page 116. That's good. There's also a high-low method example in the bottom that starts in the bottom of 116 and takes up most of 117. So those would be good ones to look at. And then the discussion questions are on page 118. I always will post the answers to those, so you can look at those questions and then look at the answers that are posted in handouts to see if you've got a good understanding of that particular topic. And then, of course, in Cengage now, you can go play with the study guide as much as you want, and that's a great way to learn the numbers a little bit. And so once you're comfortable with those things, then begin to work your Cengage Now problems, your quiz, and then the required problem for Chapter 3.